Hello everyone, welcome back. So after a long day's break, we are going to start again with our next piece by simulations. So here, next what we are going to discuss is AC analysis. So in AC analysis, we'll see how we can consider any AC sources and then how we can plot uh, the characteristics, and also we'll see how we can see various waveforms using PSPICE. So to start with, let us first consider the AC source. So for AC source, just type in V sin. So we're considering V sin. So let me increase the size so that it will be visible properly. So this is V sin. So what we have to put here? So let's see the properties. So first thing what we have to consider here is V off, that means the offset voltage. So let us consider we are going to put both name and value. That means it will be displayed in the on the main screen only. So the V of value, let us consider as 0. So offset value is always should be 0. Offset means that the amount of DC which is present along with AC. So we consider our AC signal to be purely AC. So that is why we are going to consider this as 0. Next is amplitude. So similarly, we can also put both name and value so that we can change it later on directly from the main screen. So 10 volt. Next is suppose frequency. Again, suppose both name and value. So let us consider 1 kilohertz frequency. So 1 kilohertz we can also write as 1K or HZ. Both will do. So okay. So now we have here V of value as 0. Then V amplitude is 10 volt and frequency is 1 kilohertz. So we can also change the value from here. We double click, we can change the value from here, right? So this is one new point that we have learned today. Next, let us consider the circuit. So putting other components like resistance. So first this resistance, let us consider another resistance. Let's rotate this and see what will be the output. So we had two resistances. Let's consider one more. Then just let us join them. So my wire is shown of this size because I have increased the size of my mouse pointer. So as you can see, my mouse pointer is larger. So that is why this size is also huge for the wire connection. So don't get confused. So next is ground earth. So this is ground earth. So now let us save our schematics. So for saving our schematics, so let us consider AC analysis. So for AC1, suppose, then as we have discussed, we'll put the date. So today's date is 1/12/2025. So saving is done. Now, in order to display this, so when we run this, okay, so as you can see, we have a new window here, and this new window will represent the AC analysis. So for AC analysis, we have to provide what output do we want to show here. So in order to work with this, so we have to consider this analysis setup. So in analysis setup, as you can see, we have various components, and out of these components, we have the components that we'll be using here will be AC sweep and transients. So AC sweep is used whenever we require to plot any graph. So for plotting means during plotting any graph, we require our characteristics, we require more number of points to be added. So in order to do that, we'll be using AC sweep, and if the same circuit is with respect to DC, then we'll be using DC sweep. So these two values we'll be using in various applications. We'll check those later on. So first, to starting with, like as we see in a DSO or CRO, the display of whatever be our output as per our provided input. So in order to get that, we will be requiring transients. So let us see what do we have to put here. So here first thing is print step. So that is considered as 0. Then final time. Final time means now we are defining the DSO or the CRO display. So in order to display a signal of 1 kilohertz, we'll be requiring a time period of 1 by frequency. So 1 by frequency is the time period. So 1 by 1 kilohertz is 1 millisecond. So let us consider 1 millisecond, or we can also consider here as 2 milliseconds, and 2 milliseconds will give us two waveforms. So press OK, close. Now in order to see the waveform, so we can use these probes or voltage markers. So we can put a voltage marker here. This will be across output and this is across input. So let us change the resistance values. So suppose 10 kilo ohm. This is suppose 15 kilo ohm. We are putting it random. This is suppose 5.6 kilo ohm, and this is, let us keep it as 1 kilo ohm only. Okay. Now, if we simulate the circuit, we are going to get the output, corresponding outputs. So now here, as we can see, we have two waveforms. Why two waveforms? Because we have considered two probes. So first probe is across V1, second probe is across V3. So it is shown here, the V1 in green color. So green color waveform is the input waveform which we are providing. As we know, we are considering 10 volt amplitude, 1 kilohertz. So it is showing 10 volt and 1 kilohertz. Now the output across 10 kilo ohm resistor, that is R3, is shown by the red color. So this is the red color represents the output characteristics, output waveform. So now if you want to see the value of a particular instance, that means the value of the waveform at a particular instance, so then what we have to do, first we have to select the waveform where we are going to check the value. Then we have to check this by toggling cursor. So now here the green color waveform is selected. So you can see the cursor, as the cursor is moving, we are getting some values here. So these values represent the corresponding values which it is recording as we are moving along the waveform. So this is the maximum point. So at maximum point, we are finding the value of gain, value of the amplitude of the waveform as 9.9, which is almost to 10 volts. Then next we are reaching towards 0. So this is the zeroth line. So here the value is 0. It is shown here as minus 42 millivolts. So which is almost near to 0. Now if we are going down, then it is increasing in negative direction. And finally, when we're reaching at the maximum point, we're getting 9.989, which is almost equals to minus 10. So this is for the green waveform. Now similarly, we can also check it for the red waveform. So by selecting the red signal, you can see here the maximum value of the red signal or the red waveform is, or the voltage across resistance is given as 3.27. Then minimum value is also minus 3.27. So the voltage across the output is 3.27, voltage across the input is 10 volts. So this is how we can see the transient response considering any AC circuit. So I hope you have understood this. So by using this logic, we can solve various different types of circuit. So for example, like we can go for AC analysis for circuit containing diodes, for circuit containing transistors, or various application of diodes. Like we can go for rectifier circuits, we can check filter outputs, and also we can also go for various circuits on clipper and clamper. Okay, so in next class we'll be discussing all those topics one by one, and I hope it will be helpful for you for analyzing your theory concept and then realizing them by conducting your simulations. And this is also another helpful way for you to understand that before going to your lab, that means you're before going to your practically solving your circuits using components, that means using diodes, resistances, function generators, and using DSOs or CROs. So what we can do is we can before check whatever circuit we are going to execute, we can check them beforehand using PSPICE. So that is the beauty of using simulations. So using simulation, we can verify our circuits in simulation mode before going into any practicals or before going into any experimental works. So I hope you have understood how to use or how to do this AC analysis, how to use VSin, and today we have seen how to use VSin, and then how to display the graph. For displaying, we will be requiring this transient, this analysis setup, and in this analysis setup, we will be having transients for displaying the graph. That means displaying the sinusoidal signals, or accordingly whatever we may choose. If we require any square waveform, then we will be selecting square waveform instead of this sinusoidal. If you require a pulse waveform, then we'll be accessing it by using a pulse waveform. So as we can see here, various components, like along with VSin, we have other components also, right? So considering this, we can have different types of waveform, so as per our requirements. So and for displaying, we will require the analysis setup and the transients, and in this we have to put the initial step, which will be 0 always, and the final time will be the time period of the frequency that we have considered. So in our case, this case, we have considered 1 kilohertz. So in order to display 1 kilohertz, we will require minimum 1 millisecond to display one full waveform, and we are using here 2 millisecond to see two waveforms. So if I change this to 1 millisecond, then I will be getting a single waveform. So if I run this, so this is the output. As you can see here, we are having a single waveform. So that is all for today. I hope you have understood. So thank you for listening so far. So keep joining our classes, and we'll do different types of simulations in the very near future. Thank you.